Hi, this is Josh, and welcome to JW2542 Tutoring, my SAT math course. This is a recording for my YouTube channel on lesson number 11, Exponential Equations. And I am Josh Wiener, and if you'd like to donate for the development of this course, which I've been doing for over 10 years, please try Venmo at Josh Wiener 10. And I recommend $50 per lesson, but you pay as you like, whatever you think the course is worth. But any amount of money really does help me because then I can spend more time, put on some coffee or tea, and edit the lessons and work on improving the content, the model problems, the question sets, and the support videos for this course that goes at Brooklyn Tutoring Houses for between $1,500 and $2,000 per child. So thank you so much for making this happen. This is a gift back to the community on my YouTube channel. Again, lesson number 11 this year, 2023 to 2024. All right, here we go. Exponential equations tonight. The SAT math exam itself still focuses on the following topics, mostly in 9th and 10th grade math. Algebra, geometry, the coordinate plane, charts and graphs, probability and statistics, and just a few other math topics. As you know, the SAT will be going digital, and in the new version, there's only 44 questions, but most of the math as well is focusing on 9th and 10th grade mathematics, with a few exceptions. They have a little bit on graph theory and angle relationships still, but they've taken out, for example, all of Algebra 2. So there's no unit circle questions on the complex plane, for example. You don't have to add, subtract, multiply, or divide with complex numbers, for example. You don't have to know the law of sines and cosines or reference triangles in the unit circle. Okay, so however, I do recommend if you are interested in college and would like to go into an engineering program, for example, that you are familiarize yourself with either AP calculus or AP statistics or physics, because those ones are well respected among college recruiters. Knowing that a child has, if your school offers APs, you're taking either AP calculus, AB or BC, AP statistics, or AP physics, or mechanics, or computer science, because those are the types of students who've gone through those lessons that they're interested in, and those do include, for example, Algebra 2 and the complex plane. They include if it's calculus, derivatives and integrals, and disk and washer method, etc. Okay, so you know what I'm talking about. Section 3 in the general SAT currently still has 20 minutes and 25 questions total. And section 4 has 38 questions and is a total of 55 minutes. So remember that these are standardized tests. So what you want to do is have a course to prepare for them. Either work with the tutoring house or tutoring books or a tutoring house where you have sets of lessons where you can review. For example, in my modular course that I wrote for tutoring houses, there are 28 lessons here, of which I'm sharing 22 lessons online this year. It starts with about the first 10 to 12 lessons are just algebra, and then we focus on geometry and trigonometry, angles like angle relationships, the Pythagorean theorem, SOHCAHTOA. And then the course ends with charts and graphs and probability and statistics. So this is a way to help you get organized as you want to improve your score on the SAT and get to the right half of the normal bell curve. The normal curve is used for data sets that are very large. For example, 2 million data points, 2 million students take the exam annually. So then based on the test that's given, the average score is given a rank of 500 points. It's the mean. And then half of the tests are above that and half of the tests are below that. And then what is calculated is called the standard deviation from the sum of squares. And then based on the standard deviations, one standard deviation is given a 600 score, 2 standard deviations above is 700, and 3 standard deviations or above are given the upper tail here, given an 800 perfect score. The lowest score you can get is 3 standard deviations below or a 200. If you show up for the exam, that would be the lowest score that's possible. as well. So it's all scores in math range from 200 to 800, as well as in ELA from 200 to 800, giving a total max possible score of 1600 for the SAT exam, general exam. The other thing to note is that most colleges want to see a student on this standardized test to earn a score of at least 1,000. So if you're a student working with a tutoring house, say you speak multiple languages, right? You're very much in need for universities to translate between different scientists, or even in the business world to be a translator. But they still want you to be able to perform on this standardized test with at least 1,000 score. So your first goal should be for the SAT is to get above 500 in both math and ELA, if you're going to include it in your college portfolio. Okay, one way to strategize to get to that 500 score is the following. What you do is you do the easy and mid-level questions on the SAT first. For example, in section 3, those would be questions 1 to 10, where they're clustered and ranked 1, 2, or 3, which you can see here on the bottom row. That's the rank from 1 to 5. 1 being an easy level question, and 5 being a difficult level question. So do those first, and then skip questions 11 to 15, which are the most difficult multiple choice. Then go to the gridding section, which is there in dark gray. Do any easy ones for you in that section. Then you finish the exam, check the time, say you have 15 minutes left. Then go back to the problems you skipped, work on that challenge block with the remaining 15 minutes. Also in section 4, which is 55 minutes, do the first 20 questions as fast and accurate as you can. You can see that the cluster of numbers are mostly 1s, 2s, and 3s. And then skip the challenge block 21 to 30 and go to the griddins. Do any ones that are easy for you. Check the time. Maybe there's 27 minutes left. Then go back to the challenge level block and spend your remainder of your time on those 10 questions. This strategy of skipping the challenge block, which is the last third of questions in the multiple choice, has had over 90% success rate at tutoring houses. I've been doing this for over 15 years, helping to get students perform consistently of scores between 500 and 600 on the SAT exam. Okay, so it's really good to use a beginner strategy like that as you feel more confident as you're in your reading skills and your knowledge of word exposure and vocabulary, as you become more confident, you can then work towards the next bandwidth, trying to get between 600 and 700, or 700 to 800, and so on. Okay, so again, a tutoring house can really help you get organized with this as you get ready for these problems for this standardized test. Some basic things that you should know for the math section are basic algebra, such as PEMDAS, the order of operations. You should be familiar with linear and quadratic word problems. Linear equation forms, such as y equals mx plus b, or standard form, or point slope form. If you're given a system of equations, that you should be able to add or subtract or the two equations as a shortcut, or also substitution steps as a shortcut for combining equations for a SAT standardized test. Tonight, we're going to focus on exponential equations, as I said, which here are of the form y equals a times base b to x. Okay, and we'll look at examples with exponential growth, where you can see the curve is growing as we go to the right on the Cartesian plane, or exponential decay, which you can see modeling it with the Cartesian plane. The curve will flatten out here in this exponential decay. Before we look at those classic problems and models, we're going to do what we do in the tutoring house and in the actual course. We're going to warm up with our 5 questions for 10 minutes. So what I'd like to do to you is I'm going to also put this in the chat window. Here's the link here. If you click on the blue link, you can cut and paste it. It will open up to a fresh quiz number 11 for you to try. And fill out the form with your name and email. And then after doing the questions, you can submit your answers at the bottom of the form. Again, this is an open share, so it's linked to my Columbia University drive that I received after graduating Columbia University Teachers College with a master's in math education. So it is a free resource for you if you're getting ready for the SAT. So good luck. I'm going to start my quiz. And again, thank you for all your donations over the years. If you'd like to know more about me, you can email me or watch my YouTube channel or my Wix website. So thank you. Okay, so here we go with quiz number 11. Hold on just a moment. Okay. All right, so please begin, and I will see you guys in 10 minutes. I'm sorry, there are word problems, so I always give an extra 2 minutes when there are word problems. So see you guys in 12 minutes. Good luck. Right. Okay, please finish the problem that you're working on and make sure you have an answer for all prep questions. That is time for SAT quiz number 11. All right, while you're wrapping up the quiz and you're picking your final answers, make sure you click on the submit button on the bottom of the form and the school computer saved on my Columbia University master's degree drive will grade it for you automatically. If you have further questions on this amazing content, please contact me at JW2542@gmail.com. Right, so we're going to go over the quiz in just a moment. First, I'm going to check the video. Okay, so we're going to go over each question with a method on how to solve it in less than 2 minutes. All right, here we go with our review of quiz number 11. Da-da-da. Here we go. Hello. All right, question number 1. United States dollars worth $1.30 Canadian. How many United States dollars is 50 Canadian dollars? Well, what have we here? We have a dollar USD is $1.30 Canadian. So that's US and that's Canadian dollars. So we have 50 Canadian dollars. And how much is that in US? So cross multiplying, we get 50 equals 1.3x. 50 divided by 1.3 equals x. If you do that, works out to be $38.46. So the correct answer was C. $38.46 for question number 1. And using a proportion is a good idea. Just make sure that when you do this, you set it up with like the top numerator is for one variable, for example, US dollars, and then the bottom is for the other variable, which was Canadian. The other thing that we're doing here is we are cross multiplying here. So you go across the diagonals in any proportion, they must also be equal. Okay, that was question number 1. Question number 2 reads, if 3 different numbers are selected, one from each of the sets shown below, what's the greatest sum that these numbers can have? So this one you can do by inspection. It's like a puzzle. Notice that 9 is the biggest number in all 3 sets, but we have to pick 3 different numbers. So it can't be 27. So we know B is wrong. It has to be a number less than 27. So then we have to pause and think, well, we can't pick 9 from A, set A, set B, and set C. Once you pick 9, say from set A, you have to pick a different number from set B. And then once you pick that largest number, then you would have to pick another number from set C. So the way to do this correctly is, well, let's look at set A. The largest number is 9. And then 6 and 3. But we don't pick those small numbers. But what's the next largest number after 9? That's 8 down here. So we should definitely want to pick 9 and that 8. So then look at the other set. This one has a 6 as the next largest number and a 7. Well, we want the 7 then, right, of the 6, 7, 8. So 9, 7, and 8, which gives a grand total of 24. 24 is the largest possible sum, picking 3 numbers that are different. The correct answer was A. Next one, question 3. If 3x squared equals y, 4y equals 12, what is the value of x squared y? Well, 4y is 12. So y is 3. Then 3x squared is also 12, right? Because they're equal. So then 4 divided by 3. Divide by 3. Divide by 3. X squared is 4. X is plus or minus 2. Oh, wait, x squared is 4. That's what we're combining. We're combining x squared times y. Well, x squared is 4. It doesn't matter if it's plus 2 or minus 2. Y is 3. We get a grand total of 12. The correct answer was B, 12. Question 4. Question 4 says, in the figure below, the circles are tangent as shown, and the center of the circle A is also the center of the largest circle. Okay. The radius of circle A is 2. Radius of circle B is 8. 4. The radius of circle C is 4. What is the circumference of the largest circle? Well, they give us the radius, excuse me. All right, so here's how we're going to do this one. Well, since the radius of A is 2, that means that the diameter equals 4. That's for the centered circle. Then for each of the larger circle, B, the radius is 4, so the diameter is 8 for this circle. But also for the circle C, the radius is also 4, so the diameter is 8. So to travel across from left to right along that green diameter, we have to go 8 units to here, another 4 units, and then we're traveling another 8. So that means the large circle, called big D for diameter, large diameter, is 8 plus 4 plus 8, that's 20 for the large circle. But then we know that the circumference is pi times the diameter d, and we're done. The correct answer was 20 pi. 20 pi. Right? Since the large circle is 20, that means that the circumference was d, 20 pi. The end on number 4. Okay. Let's see. Let's view question 5. Conjugate problem. 9x minus 2 times 9x plus 2. Let's see what we can do with this one. Is 11. Find the value of 27x squared. Well, I'm going to draw geometry. 9x minus 2 on this side. Okay, with 4 cells. 9x plus 2. 9x times 9x is 81x squared. 9 times 2 is minus 18x. 9 times 2 is plus 18x. Minus 4. Well, lo and behold, we can see that these cancel, plus and minus, so we can cross those off. And then what we have is we have 81x squared, 81x squared minus 4. Right? That's the conjugate pattern. That's the first and the last. Because first outside, inside, last. Okay, well, they said, but what's 27x squared? Well, what do we have now? We have 81x squared minus 4 equals 11. So 81x squared equals 15. And if you divide by 3, we get 27. X squared equals 5. So the correct answer was 5 for question number 5. The end. So I hope this review was useful to you in your preparation for your SAT exam. Let's go to the lesson at hand, lesson number 11. Okay, so we're going to focus on exponential equations tonight, and I'll just give a couple of model problems hopefully are useful to you and are standard for the SAT general exam on exponential equations. Here we go. Okay. In addition to linear, quadratic, and polynomial functions, the SAT also includes other nonlinear graphs that are commonly found in mathematics and science fields. The exponential function has an exponential term b to the x and can also have a coefficient a for multiples of growth or decay. While some students may have used this general form, f of x equals a times b to the x minus h plus k, where h and k move the graph right, left, and up and down. Let's look at a basic example. We have f of x equals 3 times 2 to the x just going to start at 0. That means 3 times 2 to the 0. So 3 times 1 is 3. Then f of 1 would be 3 times 2 is 6. F of 2 would be 3 times 2 squared, which is 12. F of 3 would be 3 times 2 cubed, which is 16, and so on. I'm sorry, 3 times 2 cubed, which is 8. So then 8 times 3 is 24. The next one would be 3 times 16, which is 48. And then the next one, 3 times 32, which is 96, and so on. Excuse me. All right, so there you can see it. And you can also see if we project backwards using negative exponents, that it'll be, since the base of the exponent is 2, we just divide by 2 each time, going in the opposite direction. So going, climbing up the table from 3, we then have we have at 3 halves, or 1.5, then 0.75, then 0.375, which is 3/8. So in other words, we have 3 halves, 3/4, and 3/8, and so on. All right. Exponential growth occurs when the base of the exponent is a number greater than 1. For example, on the left, we have f of x equals 2 to the x. So you can see that there will be growth of the function as it goes to the right, and the numbers increase positive. However, exponential decay occurs when the base is between 0 and 1. So here we have a half to the x. Since it's just a half, each next element in this integer, as we increase along the positive integers towards positive integers, will be a half as large. For example, radioactive decay or half-life will then decay. So 8 becomes 4, becomes half of that is 2, becomes 1, becomes a half, a quarter, an eighth, and so on. Here's a problem for financial growth, model problem number 1. And here we're using the growth formula for simple interest. We have that A will be the final value of the portfolio invested after T years. And we know that P is the principal or starting amount, R is the interest rate, and T is the time invested. I'm going to color code this so you guys can see it. So what are we doing here? Well, we go to the bank. Let's say we're able to save $1,000 and put it aside. That's our starting principal. So that's the amount that we bring to the bank. And we say, okay, the bank says, okay, we're going to take your $1,000 and loan it out to other people for cars and homes and colleges and whatever. And we'll give you 6%. We might charge up to 20 or 30% for our other loans, but we'll give you 6% because it's your money that we're loaning out. So you set up the base of the exponent as 1 plus the 6%, or 1.06. So then we have $1,000 starting, and the base will be times 1.06. And you can see that following this pattern, what we need to do is take 1,000 times 1.06 and raise it to the amount of time, which was 3 years. 3 years. And then you can see that at the end of, and it's how much more was it worth at 6 years than at 3 years? Well, at the end of 3 years, it has a certain value. Here, I should box that. The end of 3 years, 1,000 times 1.06 to the third power, it's already worth $1,191.02. And then after 6 years, it's already worth $1,418.52. All right, so the difference between those two dollar amounts is within those 3 years, it's grown $227 more, which is surprising because remember, it was only $60 the first year. So you'd think it'd be 60 every 3 years, it would grow $180. But no, since it's compounding, between years 3 and 6, we can already see that it's growing by much more than just $60 per year. Now it's growing, grew $227 over that 3-year period. So there's an example that really shows you how leaving your money in the bank, because then the starting value is greater, compounds it. You can see for the compounding term here, it's already 22.7% after 6 years. Okay. I'm saying that right? No, 41.8% after 6 years. Sorry. It started with 1,000. Right? So it's not 6 times 6 or 36% extra, because it's compounded. But even just by year 6, you have an additional 41%, 41.8%. Your money has grown. Okay, it's growing up. Okay, let's go to question 2. A bank offers 6% annual interest on a certificate of deposit, a CD, if you start the investment in 2017. What year will you have double your investment at this rate of interest? Well, here we have a problem set up. The final amount is double. So we're using the same interest formula, but we're putting in place. The original amount is X, the amount you bring to the bank, but you want to double that amount of money at a base rate of an extra 6%, so 1.06. So then 2x divided by x gives us the constant 2. So we want to know, when will our multiplier, 1.06, our compounded base, raised to the power t equal 2, meaning our initial amount x has been doubled. We log both sides in this case, because we can use the log rules for exponents. Then we have the log of 2 equals the log of 1.06 to the t. But the rule was, when you have an exponent log, remember exponents, you just bring the exponent down to the front. So that means that we have t times the log of 1.06, right, from our rules of exponents. So dividing both sides by log of 1.06 now, we have log 2 divided by log 1.06 is 11.89566, meaning that it'll take 11.9 years, 12 years, for your money to double at 6%. Notice that this is not simple interest. 6 times 12 is 72%. But since the money is being compounded, it does not take, what would that be? 6 times, I don't know, 17 is 102. It won't take 17, or it will just take 12 years for your money to double the compound interest. Okay, next problem, bacteria growth. Here, a science lab is cultivating bacteria with the student lesson on bacteria growth. The bacteria population doubles every 8 days. If the sample of each student group starts with 3,000 bacteria, how much will the population increase after 40 days? Well, 8 times 5 is 40, so that means 5 periods, right? Here it is, yeah. The amount final will be the initial amount, 3,000, times 1 plus the rate. It's a doubling rate. So 2 is the base of the exponent. Will double or be times 2 every 8 days. Well, we set up the exponent for time as side work here, and it says, since we have 40 days total, we compute t equals 40 divided by 8 equals 5 cycles of time for this bacteria population. So don't forget to divide by 8, because it has a doubling rate every 8 days. Okay, so then that's 5 doublings. And 2 to the 5th is 32. So then 32 times 3,000 is 96,000 bacteria. So, for example, you take that old moldy bread, you put it in the refrigerator, you're like, okay, we'll come back in 40 days. The moldy bread on that plate that was 3,000 units of bacteria now has 96,000 units of bacteria on that moldy bread. And the question was, how much should it increase? So don't forget, 96,000 is a trick answer. you have to subtract the initial 3,000 to say that it increased 93,000 in 40 days. Okay, so it increased, how many percent is that? 30, oh boy. 31 times the initial amount. 3,100%. 31 times. Right. Depreciation of value. Here is a basic example. Say you buy a computer, trading company states that you buy a new computer and it loses 15% of its value every year. How much is a $2,000 computer worth in 4 years? Well, here, instead of adding the base exponent, be careful because you have to subtract the percent when you set up the base of the exponent. So for this example here, notice that it's 1 minus the 15%, 1 minus r, because it's depreciating, it's losing 15%. Then you have 2,000 times 0.85 raised to the 4 years, right? Not 1.15, not adding the 15%, we're subtracting. And that gives us a value of $1,044.01. The correct answer was D. After 4 years, the computer is worth $1,044.01. Excuse me. Last one, radioactive half-life. Well, here's another one for the SAT where we're going to use that log both sides step. It says the half-life of a time it takes for radioactive sample to decay to half its initial value. So uranium-238 has a chemical half-life of 4.46 billion years. How long will it take for a 10-gram sample of uranium-238 to have 2 grams present remaining? All right, now, this is a problem on nuclear waste from nuclear websites, but also from nuclear meltdowns such as Chernobyl or Fukushima, or also waste from testing nuclear bombs and weapons. And so those released radioactive elements are very dangerous. They're often kept in bins and buried underneath mountains. There's also talk from the space program of launching the radioactive stuff off the Earth out into space, get it off the Earth, just send it off into the distance. This is true. This is how do we have to handle dangerous waste such as uranium-238. Turns out that what we have to do is we have to set up the following equation. A half means 50% less. So same thing, caution step. What we're going to do is we're going to do 1 minus a half. Well, that's 100% minus 50%. That's 0.5 is the base of this exponent for this problem. So 0.5 to the t. We started with 10 and we want to make it down to 2. So then dividing both sides by 10, we get 0.2 for our decimal. That's where we want to get to, that ratio. But we want to know based on the base of the exponent, 0.5. So again, same thing, log both sides. You get log of 0.2 equals log of 1.5 to the t. Bring the t to the front, and we divide by log of a half. So it's log of a fifth divided by log of a half, which is 2.32192 half-lives. But that each half-life takes 4.46 billion years. So the correct answer is 10.374 billion years for that uranium to cool off. So that the uranium present that's radioactive goes from 10 grams to 2 grams. All right, so 10 grams could make a community sick or be dangerous for a town or a village. And 2% is the safe level, right? 2 grams is the safe level. Then that sample will take 10 billion years to be safe again in that community. All right, so it's very serious stuff when we're talking about radioactive waste, and making sure that folks, it doesn't poison the waters, give folks diseases or cancer, or be dangerous for the community anyway. I know that on the news this week, 2023, that not the prime minister, but one of the head businessmen in Japan not for TEPCO, but for other companies, went and ate some sample fish from Fukushima because they started dumping the water from the plant that melted down from reactor number 4 that melted down. And so they've been managing the waste, and they promised, they said, well, we've been managing the waste and have been adding the chemicals and, and trying to flatten the curve on the half-life so that the water's safe. But they dumped like hundreds of thousands of gallons of radioactive water into the China Sea. So China banned all exports of seafood from Japan, and so did some other countries. Taiwan, the island nations down below, they're part of the currents. And so everyone's very angry at Japan for their handling of the Fukushima nuclear tragedy 311 from 311. All right. Let's go to the lesson today. So it's time for the classwork. You'll have 20 minutes, work on odd problems only for SAT lesson number 11. And what I'd like you to do is just try your best. Notice that there are basic plugins for the compound interest equation for growth or decay, but there's also problems once in a while, the advanced problems use that log both sides step, whether it's radioactive growth, such as financial investing, or radioactive decay, such as handling radioactive elements in a science class. All right, so I'll give you guys 20 minutes. Again, I'm going to put my timer on. So good luck. I will see you in 20 minutes for SAT lesson number 11, exponentials. Okay, that is time for classwork number 11, odd questions only. And what I'll do now is I'll reveal the answers to SAT classwork number 11. Here we have for these 25 questions, 1 was B, 2 was C, 3 was C, 4 was A, 5 was A, 6 was A, 7 was C, 8 was B, 9 was D, 10 was C, 11 was D, 12 was C, 13 B, 14 B, 15 was A, 16 C, 17 B, 18 C, 19 A, and 20 was A. 21 was 81, 22 was 599, 23, wait a minute, these are incorrect. Same thing as last time. I forgot to refresh the form. So sorry, guys. Let me fix this. Gotta refresh the form. So while you're working on, I'm working on it and checking the bubble sheets. So let's go over that one more time. SAT classwork 11. 1 was C, 2 was A, 3 was D, 4 was C, 5 was D. 6 was D, 7 was D, 8 was A, 9 was B, 10 was B, 11 was B, 12 was D, 13 C, 14 C, 15 C, 16 D, 17 B, 18 B, 19 D, and 20 was A. 21 was 6.11, 22 30, 23.72, 24 134, and 25 was 2.274. All right, to end this class, let's go over one easy, mid, and one challenge level question. And you can see here, since we're doing lesson 11, odd questions only. Question number 3. A bank offers a college loan with a 14% annual interest rate. How much will a student owe after borrowing $50,000 after 5 years? So the amount final will be the principal times 1.14 raised to the 5th power. Let's figure out what the multiplier is just by doing 1.14 to the 5th. We get 1.92. Number 2 will be a doubling of that number. If you multiply by 2. So we get 96,000, nearly 100,000, 96,271. The correct answer was D for question number 3. Question number 5. An auction house claims that the painting by a renowned master painter increases in value by 3%. If a painting is auctioned for $1 million, how much will the artwork be worth after 25 years? Well, another classic compounding value. Here we have the amount final will be 10 to the 6th times 1.03 as our base, an extra 3% after 25 years. Let's find out the multiplier. Well, just 3% growth, 1.03, but compounded 25 times is a multiplier of 2.09. 377,793 times 10 to the 6th, which would be 2.094 times 10 to the 6th, or 2.094 million. The correct answer was D, 2.094 $1 million piece of art. Cool beans. All right. That's for question number. Go to the challenge ones. $15. A computer chip company claims, word problem, every year its processors are improving within the computer. Every year they're 45% faster. Oh, following Moore's law, that kind of law. 45% faster than the year before. Which curve represents the speed of the processor after t years? If variable s is the speed at the start, the speed at the start is s. Right, that's the same for all of them. All right, but 45% faster means that the base should be 1.45. I only see one that's like that. There it is. That was easy. It has to be C is correct, because no other one setup has the base of 1.45, 45, 1 plus the 45%. So the correct answer was C. All right, so if you know the template for these are kind of not that difficult. All right. 19, 21, comparing 23, stock price. 25. Let's do, or we can do challenge level. Let's do China here. The world's population has grown at an average rate of 1.9% every year since 1945. There were approximately 4 billion people in the world in 1975. No, the world's population, not China's population. So the amount final is the starting amount, the initial 1.019 raised to, we're comparing years, so 1975 minus 1945. We're going to subtract those. So they're saying that 4 billion is the starting amount in billions times 1.019, 1 plus 1.9%, to the 30th power. So let's find out the multiplier. Not 3% of the 25, but 1.019 raised to the 30th means that it nearly doubled in that 30-year period. 1.7588367 times the initial amount gets us to 4. So then 4 divided by that number, 4 divided by 1.7588637 is 2.274. Was the initial population in billions. 2.274 was correct for that problem. So make sure as they round to the nearest thousandth, 2.274 should be typed in to the bubble sheet. All right, that's it for today's review of exponential equations, an easy, mid, and challenge level problem. And wrapping up for tonight, there again is the proper 25 answers to the classwork. And here are the links to the quiz, classwork, and homework for today. I invite you to come to my Wix website, JW2542 at Wix.com. And for over 15 years, I've worked with thousands of students to prepare them for tests such as the New York State Regents, the Specialist High School Achievement Test, the test for admission to Catholic high schools, the Cooperative School Exam, the High School Placement Test, PSAT, SAT, ACT, AP exams in calculus, statistics, and physics, as well as the Graduate Record Exam. I've worked with grades 5 to 12, additionally college students and grad students to get them into their programs of choice. You can see praise from parents. And if you'd like to work with me as a one-on-one tutor, please email me at jsmw2542@gmail.com or call me at the number on the screen here. If you'd like to donate to the development of this course, please go to Venmo for Joshua Wiener 10. And I invite you to donate $50 per lesson or whatever you think the lesson is worth. Here we have the links to my Columbia Drive for Quiz 11, Classwork, and Homework 11, and I will see you next week, November 28th at 7 p.m. for the next class. I hope you have a happy Thanksgiving, and remember you can check out the full set of this podcast on YouTube, which I'll post, and you'll have the full set and access to these forms in perpetuity. For my lifetime account from graduating Columbia Teachers College with a master's in math ed. Anyway, thank you so much for joining me, and this is a gift back to the community, sharing these 22 lessons, and we're halfway done. That's lesson number 11. Okay, take care, and thanks for studying with me. Okay, bye-bye.